Hello, everyone.
Hello.
This is
Kylie.
And that is
John.
You guys are back from Antarctica. Let's see what I can get you guys at the stars. I'll just leave them here. My voice will come from over here. Maybe we'll adjust it as we go on. Oh, look at that. Behind you is the Geophysical Institute here at the University of Alaska Fairbanks. Wow, that is very sensitive. Yeah, that worked out a little better. Okay, thank you for... oh, look, there we are. So as we go on this afternoon, I'll lean in so that we can see who's the tallest. So thank you for taking some time to talk about your work. I know you've probably got a lot of stuff to do. You've got some data analyze and all that sort of stuff that scientists... What do scientists do all day? What do you do in your offices?
So a lot of coding for me. I work on geophysical inversions, so we have these instruments that are collecting data literally all over the world, and we collect that somewhere, and then I spend a lot of time fixing small bugs in what I thought was simple code I wrote. But,
what are you doing in your office or your lab?
I'm working on writing a paper currently. So.
Oh,
yeah.
Is it as frustrating as any research paper? You're like,
Yeah.
oh, my thesis is terrible. What was I thinking?
Yeah, pretty much. So I'm currently waiting on feedback. So got some downtime, but we're also going out to Poker Flat at night. So
yeah.
And
we sleep during the day sometimes.
Oh, nice. Well, thank you for getting up a little early today. I know they just did a launch last week, right? And there's another mission that's standing by right now.
The Super Soaker mission.
Mm-hmm.
Yeah.
I've seen videos of that. So like the little rocket, and then it burst off a lot of little stuff at the bottom.
So what we're going to do is launch a big drum of essentially water up into the atmosphere, blow it up, and try to create some noctilucent clouds.
Okay, that's not what we're here to talk about, though. That's really, really exciting. That sounds super cool. Okay, so excuse me. We're closed in here. So first off, thank you so much for sharing from your time in Antarctica and the South Pole and all your trips down there. I know researchers have so much to do and there's so much limited time, and that you took the time to share stuff with us is really great, and engaging with the people in the group. And thank you, group members, for joining and watching all what's going on. And as we're talking, if you've got any questions, post them, and I'm monitoring on a couple of places, and we'll be able to get your questions answered. Oh, Valinda says hi. Welcome back.
Oh, hello.
Thank you.
So let's talk a little bit about just how you get down to Antarctica.
Lots of planes.
Lots of planes. So I might ask you, fly from Fairbanks to Seattle, and Seattle then somewhere around to...
San Francisco, and then San Francisco to Auckland, Auckland to Christchurch. Then Christchurch will go to the ice, to McMurdo.
So down to Christchurch is commercial airlines, about 2 days worth of travel on commercial airlines.
Mm-hmm.
And then we have 2 days worth of travel to the South Pole on military cargo planes.
Oh, my.
Yeah.
And I saw that in the picture of you guys all sort of just in the droning background of the plane. For an hour? How long is the flight from Christchurch to McMurdo?
8 hours.
Yeah, it's 8 hours,
Yeah.
a little longer, but maybe 8.5 hours. We had to do a couple attempts, I think, at landing on ours, if I remember correctly.
3.
Yeah.
They circled McMurdo 3 times.
Yeah.
Before we landed.
That makes me think about one of the questions I had, because I know you stayed there a little bit longer than after you were done with your research. So do you build that sort of emergency funding into the grant that you're getting, and we might need to stay an extra couple of days, or is it just a little wiggle room in that? So
the NSF will handle all of that internally. It's all NSF organization. Mm-hmm. All the housing and lodging and everything is NSF. So all we have to really consider, they handle all of that for us. We just consider our schedules. And yeah, absolutely, you expect to spend up to a week delayed at each location, and that's just what we plan for. And
do they have the food down there?
Oh yeah, absolutely.
Oh, okay,
yeah.
So that's
McMurdo is a very large base. It can house 1,000 people. And
I think there was about 700 when we were there.
Oh,
yeah.
my.
A little over 700.
So that's the hub for most of Antarctica. Certainly the American programs, and actually other programs. The Kiwis stage out of
New
there
Zealand.
too.
Mm-hmm.
Yep.
Thanks, Kylie will be here translating. Since it is summer there, was it like the midnight sun here? Did the sun never go down while you were there?
Oh yeah, no, it never goes.
It just circles.
It just
Is that disorienting for you?
Oh, yeah.
Yeah, absolutely. Yeah, it could be 1 a.m., 1 p.m., 5 p.m. It doesn't matter. It looks the same.
Time is meaningless.
Yeah, really. Yeah. You have to. Luckily, the kitchens there maintain a very specific schedule, and if you can kind of set to that schedule, you can have a sense of when to sleep and when to be awake. But there's no cues from nature at all. Yeah.
And it's a 24-hour thing. I'm sure scientists have 24-hour projects.
Oh,
that
yeah,
are going on.
absolutely, yeah. Yeah, there's always something going on, especially at McMurdo being a larger base. You can get a helicopter at 2 a.m. if you need one or something. You know, I mean,
like an Uber, you just got an app, you get the helicopter
yeah.
land.
They run 24/7. Yeah.
The other question I had about that is like there's such this grand history of polar expeditions and polar science, and down there literally time is frozen. You saw some of the first buildings that were built down there. What's it like to see those things? Smelly, I understand, is one of the things that.
The Scott base wasn't that bad.
No, the Scott's Discovery had everything is still frozen from when Scott was there, and so there actually hasn't been a lot of decaying or aging of any of the insides of the Discovery Hut. There's actually a seal they were harvesting when they left.
That's creepy.
That is still inside and mostly preserved.
And there's pictures from that in the group, so you can go back, explore some of the pictures. You can see some of the stuff that you guys saw. So you went down there to do a very specific job. You weren't down there as tourists.
Right.
What did you go down there to do?
So we went down there for annual maintenance of our scanning Doppler imagers that Mark Condi is the principal investigator for up here. It's the summer down there, so it's daylight, and because it's daylight, the instruments don't run. So we're not doing any data collection when we're down there. With the instruments. What we are doing is they're very complicated optical instruments. They need alignment. They're actually incredibly sensitive. You would never think to install something like this at a place like the South Pole, or we have some instruments up on the north coast of Alaska. It's just they shouldn't run for as long as
they shouldn't run.
They really haven't. But Mark with the machine shop here, working with some other gentlemen, have constructed and engineered a solution that is capable of withstanding 12 to 18 months in these severe environments. But that being said, someone needs to go down every 12 to 18 months and realign the optics of the instrument because they're getting rattled loose.
The buildings shake.
Yeah, the buildings will shake.
Is it the seismic activity, or is it
it's
just
the wind? So
the wind?
Yeah. So, for instance, it's a different site, but we had our site up in Kaktovik. The wind actually blew so strong up there last year that we have a $250,000 filter up there that had worked.
No one's watching. You're fine. You're fine. $250,000 piece of equipment.
And it looks like a 5-gallon bucket in size, and it had wiggled itself loose from the building shaking so hard that it wiggled itself loose and actually bent the bolts that were holding it on.
Yikes.
Yeah, and this is a very sensitive optical instrument that measures a precision smaller than the width of an atom. And they're able to.
That's really like I can't make that small of a thing.
Yeah.
Smaller than the width of. Keep on going. I'm sorry. My mind is just thinking about what that would.
We're making physical changes to spacing smaller than the wavelength of light, and this instrument is surviving, and all 6 of ours, 2 in Antarctica and 4 in Alaska, somehow are engineered to survive for 12 to 18 months.
That's amazing.
Yeah. Or one at the South Pole when we showed up, though.
Good. No, this is what we want to hear about.
Yeah.
Well, actually, when we were at the South Pole, we got emails that Tulik up here went out, and so did Eagle. So at one point, there was 3 out of our 4 in Alaska that were down too.
So yeah, this is.
It happens all the time.
Yeah, this is our summer trips are designed to go and bring the instruments back into a state in which they can run for another year, and. So
hopefully that happens.
But
it's possible that things can break again over the winter.
Our job is to hopefully
to do a good enough job.
do a good.
So Dr. Condi could be like, "You guys, 3 months, you did not do a good enough job. F." Well, you're PhD candidates, right? And so
technically, neither of us have moved to candidate.
Oh.
Yeah. So there's a process to in the field of physics, it's a little different than other PhDs. You go straight from a bachelor's into a PhD program.
Skip that pesky master's. Who wants that?
But there's some stages along the way. So this university, the big mark is a comprehensive exam. So once you do a written comprehensive, which is the bulk of your testing for a PhD, you then do an oral comprehensive, which is less significant, and then you're a candidate. So I've done my written comprehensive. I have to do an oral comprehensive, and then I would be a candidate. And Kylie's.
I haven't done anything. I'm not there yet.
Do they have you like a practice test? And here it's like this, like, oh man, I'll just.
So you get.
I'll think about it.
You get packets of the previous 10 years.
Yeah, you get 40 exams.
Oh my.
Yeah, but they come out in January, the year you're going to take the exam. So the exam is in August, and I'll take it this August, but I haven't gotten the packet yet. So
whoever's sending her the packet, get that packet out there. So it's amazing that as the level of students that you get to go on these science expeditions. Is that unusual? Did you meet other people like your peers down there?
So down in Antarctica, you're surrounded by people that are just like you. I mean, that's common. Yeah, it's everyone. But in the global scheme of things, it's an absolutely rare opportunity for somebody that's 1 or 2 years into a graduate program to have the opportunity to travel to a place like the South Pole. That is extremely, for anyone in their lifetime to travel to the South Pole is extremely rare. But for graduate students that just beginning into research, it's an incredibly rare opportunity.
It's on my bucket list. So next year when you guys get ready, just write me right in there.
Yeah.
I'll just you can pack me.
Yep.
So the equipment, it's scanning way up above Antarctica, the atmosphere, the upper levels. Like how high up are the cameras looking?
Yeah, so the camera is looking at several different altitudes actually. What we're doing is looking at different phenomena at those altitudes is how we know how high they are. The highest one is 250 kilometers. It's kind of up by where the International Space Station is. So it's outside of the near-Earth boundary for space. So we would technically be looking in space, but for people like us, we would still call it Earth's atmosphere.
But if you were an alien.
Yeah.
Speaking of, we asked if they watched John Carpenter's The Thing down there. John has never seen it.
I'm totally clueless.
So just don't watch it when you're down there. One of the things that made me think so much about The Thing particularly, and there's a question about that as well, is the tunnels that are under the South Pole, because there's scary monsters that are chasing the people around in the base in the movie. So one of the questions is, were the cave corridors, do they make noise with daily temperature changes? Is there weird like ice squeaking and stuff that you hear, or is it just like deathly silence when you're down there? And there's pictures of the tunnels. If you don't know what I'm talking about, go look in the group. There's some pictures down there.
So I didn't hear any ice-related
but
settling
big
noise.
Tubes where stuff's going through them, so there's that noise.
There was occasionally you would be walking and you
like toilets flushing sounds.
So it is the fresh anesthetics. Yeah. So you have the inlet and outlet going past you there. But it turned out, I was talking to somebody back up on the surface, and they said that rushing sound was actually vehicles traveling over.
Oh, really?
Yeah, it was traveling through the ice. So you would be walking, and then you would just hear this kind of low hum, and it would build and build and build and build, and eventually it was just an overwhelming sound. And it really gave you the impression the whole tunnel was about to collapse. And
there's nothing you can do.
There's nowhere you could run or anything.
No.
I mean, you're just there.
You're just waiting for it.
But it turned out what it was vehicles traveling overhead and then just echoing through the snow.
Would you say it was the Doppler effect that you were hearing?
There was a Doppler effect. Yeah, absolutely.
Can anybody just walk down there? Do you have to have a special permission? And you told an anecdote of how you sort of got disconnected from the base and they might have been started worrying about you.
Yeah. So for the tunnel, the National Science Foundation, very obvious for obvious reasons, is very concerned about safety down there. Humans are not designed to survive this environment, and so for things that they do a risk analysis on everything, every possible outcome, any research you do, any travel you do, anything that you would do has a risk analysis done, and for that trip down to the tunnels, the risk analysis requires that you have a plan. So you have to check out with the base, and you have to have radios, and you have to return by the time you check out, or they'll come looking for you. And so yeah, we did that, and
we left John in charge of the radio.
Yeah,
it was a mistake.
So somebody handed me a radio, and we went down there, and we got about 10 minutes from the check-in time, and so I was just going to radio back to check in. So I hit the call button on the radio, and called out for the base, and no one replied. So I called back again, no one replied. Did that 5 or 6 times, and finally it was getting close enough to time that the base was going to start coming to look for us if we didn't check in, and so we hooved it back and. We were moving.
In our big heavy gear, it's negative 60 down there.
Oh.
Yeah.
Come on.
Fun.
Yep.
John trips. You're like, leave me behind. Go, Kylie, go. Let him know I'm okay.
Well, he had the radio.
Take the radio. He's got his broken ankle. I'm sorry. No, that's just me imagining. It wasn't anything like that.
Yeah. It's only 2/3 like that. But we got back there, and some other events had happened. But the long story short was that at the South Pole, we were just handed a radio. The radios at the South Pole are specific in that you have to, it's like a phone. You have to call a specific number in order to communicate with somebody. So I was hitting the calm button, but I had never called anybody. So I was just calling out to open space.
Unfortunately, no one answered.
It would have been kind of weird. Yeah.
So the cameras are looking up way high above the planet. What are they looking for? What do they want to see? The phenomenon that you mentioned.
Yeah. So the phenomena that we're primarily interested in is called air glow. We look at auroral activity as well. Ultimately, we're looking at the emission of atomic oxygen, and the mechanism by which we look at that varies sometimes. But we're looking at two colors in the sky. We're looking at red and green, just like a red and a green aurora. In fact, it's the same mechanism, and we'll even look at red and green aurora the same. The red in the aurora generally is higher. It's at about 250 kilometers altitude, kind of out by the International Space Station. The green, as most people that see the aurora know, is towards the bottom of the aurora, and is usually at about 120 kilometers altitude. So we're observing both of those, and that really precise instrument that I was talking about that had bent the bolts and almost fallen off.
Very precise.
Yeah. If NSF is listening, it was safe.
Everything's okay. Or the engineers. It was all good. You did a good job building it.
That instrument is capable of looking at only the very specific wavelengths of those emissions and nothing else in the sky. And so that's where we get the ability to do this. Is kind of like if you had a camera and you could put like a red filter on that camera or a green filter. We do the same thing, but we do it in an extremely precise fashion, and then we do it in a way that we can change the color. The instrument that we have could break the visible spectrum into trillions of colors, and whereas we usually think of like Roy G. Biv, right?
Right. Yeah.
There's millions of colors of red that this can segregate into. And,
do you have names for them all? Pet
I have red, slightly more red. A
little bit more red than the last red I was talking about.
Yeah.
So you're looking at just that wavelength, just that color.
Yeah, and from physics we know the height at which that phenomena is occurring. For the red color that we're looking at, it's pretty stable. A lot of people are not aware of this, but as you get really high in the atmosphere, it's actually incredibly stable. The temperature varies with altitude. It gets warmer as you get farther away from the Earth. And in addition to that, the particles start to segregate by which type they are. And so you might have a layer that's mostly oxygen and a layer that's mostly nitrogen. And so
it makes me think of like when you look at cutting into the ground and you see the different levels.
You'll have the stratification layers. Yeah. And so for that red emission, it pretty well sits at about 250 kilometers altitude, and it's really diffuse. It's really, it looks like fog or something. It's very broad. The green emission, however, as people that are aurora watchers,
that's what I say.
the green emission, just as the bottom of the aurora, and you'll see move around all over the place. The green emission varies in height quite a bit. And we actually need adaptive models for that. We need to be able to know what the physics tell us based on the situation that's in front of us. And so finding out what height we're observing it's a non-trivial thing to do.
So she's got the harder job.
Oh, wait,
Not
an easy street. 250 kilometers, move on, next thing.
Why study this? Why is it something that you're interested in? How does it help humans better understand our planet and the Earth system?
So if you have a satellite in space, like you said, the red emissions are right where the International Space Station is nearby. So what we are actually looking at is the thermospheric winds. So using the emissions, we can find the winds that are happening up there, and we can tell like what's what's going on? What are we about to fly into with this satellite? And it's important for the trajectories.
It's similar to maybe when you're flying on an airplane across the continent, and you might have a headwind or a tailwind, and that's going to affect how much fuel you need to burn and what direction you need to point your plane in. You might need to veer a little bit off in another direction. The same thing happens with satellites. So they try to conserve energy a lot more than an airplane would because they can't land and refuel. And so knowing what kind of weather they're flying into, because there is weather at these altitudes, it's a little different. But what kind of weather they're flying into, what kind of winds they're flying into, becomes very important and as was the case in, I think it was 2009, there was an old Soviet satellite that was no longer operational, but it was being tracked by NASA. And then there was an Iridium satellite, like the sat phones that you use. And they were scheduled to miss each other by about 5 kilometers. It was a near miss.
That's pretty close in space.
Yeah. But there was not really much data. There was no thermospheric wind data. Yeah. And as the projections got closer and closer to time, the scientists had concluded based on the data that they were going to miss. But it turned out that they didn't anticipate that the wind was changing, and they smacked each other and just blew up like a shotgun blast across the sky. And the folks at Iridium lost a couple $1 million, and then there's a few thousand more pieces of debris
flying around up there to get caught up in the space winds.
Yep.
So, and satellites are important for just communications like we're doing right now, who are watching streaming stuff on Facebook anywhere, or any communication.
Oh yeah, they're integral to our life today. I mean, there's you don't go 10 minutes without using a satellite anymore. It's your car's using it for your OnStar services, or you're using it your phone for your GPS, or being in Alaska, a lot of people in remote villages are using satellites for their communications, just period, whether it's a phone or internet.
So the equipment that you made sure continues to work help make sure that you can see what's happening up there and predict the weather? Are there weather forecasts that they do and things like that? Is it more just like...
We're a little early on in the modeling to be able to do forecasts like you would imagine at a lower altitude. But we can do estimates for transport. So if, for instance, like a nuclear power plant in Japan blew up and...
Just saying, it might, you never know.
Yeah. And lots of radioactive material was released into the atmosphere. If that had traveled high enough to transport into the thermosphere, we could model that transport. And there have been cases in the past where a volcano erupted, maybe in southwest Alaska or something like that, and you wanted to know where that plume was going, or a radioactive plume of volcanic ash or something.
Something going up.
Something going up. And there have been cases in the past where we've done that, where we've modeled the transport in the upper thermosphere. The transport in the upper thermosphere can happen over years. So what people think of as a local event, a small eruption, can actually move into the upper thermosphere and transport all over the world, and it can transport for very long periods of time before it comes back down into the atmosphere.
Is that wildfires as well and all that sort of, or does that not get up quite so high?
Actually, I don't know the answer to that.
Yeah, I don't know. You're a physicist. So when you look at the aurora, do you see the pretty colors, or you just see that's data I should be collecting right now?
Oh, we definitely still see the pretty colors. We both do photography, so we go out and take pictures just like everyone else.
Let's see. There's another question. How does minus 60 feel without the gear?
Colder than minus 50.
You can really tell. I mean, is it different? Like, it's 20 below outside right now?
Yeah, to me it feels the same. The difference that I notice is just the extremities stop working faster. But the feeling is just the same for me.
It's just cold.
Yeah, it's just cold.
There's no wind.
Yeah, so you're down in a tunnel. It's just how fast the heat transfers up from your body to the atmosphere. The South Pole is a desert. It's completely dry down there. They get something like 4 inches of snow a year. It just never melts. So there's not a lot of moisture to conduct that heat off your body. So people think of this in different contexts, but air is a very good insulator. It's actually one of the best, and some of the best materials used to insulate just create an air pocket. And so when you're down at what is a bad insulator is if you got a lot of moisture in there. So if you're in a moist environment, 20 degrees may feel colder than minus 20. And so down at the pole, there's very little air or very little moisture in the air. And so even though it's minus 60, that heat's not transferring from your body to the atmosphere very fast. So as long as you've got your skin covered, it's actually not too big of a deal.
So you wear the big park, just some gloves, little hat, scarf thing.
Yep.
Mom knits you a scarf, you're good to go.
Yep.
That's pretty cool. What makes it better to look up from the Earth rather than down from a satellite to collect information about the aurora and the other phenomenon?
Awesome question. It's cheaper.
Okay, there you go.
Yep, and
so especially with the green winds, one of the only other ways we can, well, there's multiple ways we can get data in that height range, but one of the other best ways is to do these rocket launches like we're doing out at Poker Flat right now, and those are
cost-wise?
Yeah,
that's
a lot.
Millions.
Yeah, and then it's so much time to go into them too because it's years of planning, and then you launch a rocket for a few minutes, and then there it goes. And that's all your data.
you only get in space-time, in terms of a spatial location at a time, you only get a point of measurement. So the rocket's traveling through time and space, whereas our instruments are sitting and they're looking at a uniform spatial grid. So you can measure multiple instances of time at the same spatial location with our instruments. A rocket, while it's going to give you the ground truth, there's no arguing when you travel through a region that measurement that you're making right there is correct. It's only getting one space and time correlated point, and you move on to the next time and a different space as well, whereas our instruments can record the same space over multiple time series. So
it's amazing to think about. It's just, it's really cool.
Yeah, so the rockets are incredibly useful. I mean, there's no other way to get that information that the rockets get, and it is the ground truth. It's if a rocket gets a measurement and our instrument gets a measurement, and they disagree, our instrument's wrong. There's no question.
And satellites can't orbit at those height ranges.
Yeah.
So that's another issue.
There's still too much atmosphere for a satellite to sit down at those altitudes. Mm-hmm. So that wind that we were talking about would actually force the satellite down to Earth. It would bring it down pretty quick.
We don't want that. Stay up there.
Satellites.
Stay up there.
Yep.
What's it like to try to get the funding? If you go down every 12, 14 months, that's like regular funding. Is it an unsure every time if NSF is going to do that?
It's built into the project that Mark. This is the principal investigator, Mark Condy. Took care of he takes care of all of this for us. We
he's gone enough. I mean, I've seen pictures of that he. I think I shared some of them from the 70s and the 80s of him.
He's got to have some experiences that actually no other people on Earth will have. Dogs are an invasive species in Antarctica, but they weren't declared that until shortly after Mark's last trips down to Mawson. So he actually got to drive sled dogs down in Antarctica, and no future humans will get to do that. That's something that I'm very jealous about.
So he says, okay, I've got this all set up, and you're the team that's going to go down this year.
Yeah, so through the NSF, Mark's got a grant for these 2 Antarctic SDIs, one at McMurdo Station and one at South Pole, and included in that grant is the need to service them. And so Mark has an agreement to go service them annually. It's because he's a very nice guy who's interested in the future of us that he allows us to fill those slots and go down there.
Well, I find that a lot of the faculty members and the staff members here at the university is they're here because they want you to have the experiences. They want to provide that for you, and the GI has been doing that for years. So
absolutely. Mark's no exception. He at his own expense, he'll get won't tell us sometimes, but he'll give us the opportunity to go out to go do things that really are unique and good experiences.
Thank you, Dr. Condy.
Yeah, thank you.
We have time for just a couple more questions. 5 minutes left. There's a question: are penguins more amazing in real life?
Yes.
Wild penguins.
Yeah. Wild
not
penguins.
The ones in the zoos.
Those look sad.
Yeah. No, the penguins are the cutest animal on the planet, bar none.
Do they make a sound?
Yeah.
Yeah, they make a little
Sometimes.
like a.
Like a pee-pee?
Yeah, like
Do it.
I can't do it. I'm
Watch a YouTube video. I'm
Yeah.
sure there's YouTube out there about penguin sounds. The thing I noticed in the pictures that you shared of the penguins, which I hadn't really noticed before, is their big sort of talony
Yeah.
feet things. That was crazy to see.
Yeah. Yeah, that one, there's one particularly that I got a good full body shot of that just had these just crazy huge feet, yeah.
I did not expect that. What's the social life like? You mentioned that you'd watched some Game of Thrones that you'd never seen before, Kylie.
Yeah.
And I asked you about The Thing, which you hadn't seen before. It's not like required viewing when you show up at the South Pole. I do want to do a live stream of watching it. So anyway, but what else? I mean, do you guys hang out with the other researchers? You mentioned you had seen another Fairbanks-based researchers project.
Oh, yeah, that was, so actually last year, when Mark Conde and I went down to the pole together, when we were getting onto the plane to head back out. So the planes, when they land, they don't turn off. They land, and as they're stopping, they're unrolling the cargo doors, and the forklifts are coming up already. It's all a very fast, hurried thing. The forklifts are coming up, they unload the cargo, they unload the passengers out the other end, new passengers come on, new cargo comes on, and the plane takes off. And so as we were getting on the plane last year, we were walking past the people getting off, and one of the people getting off was Bill Bristow, who was another researcher here. And we're just kind of like, 12,000 or 11,000 miles away.
Like the Seattle airport.
Yeah. Hey, Bill, how's it going? Good to see you, Bill maintains the Super Darn Array, which is looking at a similar type of thing that we are. We're looking at particles that are not charged. They don't have an electrical charge to them. They're electrically neutral. Bill looks at the same regions in the atmosphere, but he's looking at charged particles, ones that have an electrical charge to them, call them ions. And so he's working kind of in a similar area that we are, and in similar geographical locations as us. So
Crossing paths.
Yeah, crossing paths.
So if you're hanging out, I'm not saying hang out at night because there's no night, but when you're off time, is there pool tables or all the stuff that you would imagine?
Music rooms. There's a greenhouse at the South Pole.
There's gyms,
art and craft rooms, gyms. They always have something going on, whether it's like volleyball or Game of Thrones night.
The NSF is actually not just in Antarctica, but up here in Alaska. We have a long-term ecological funding up here with through the NSF, and they are pretty big on health and wellness. And so they have some of the places have saunas.
So it's really to help you tune out some of the work that you do, because otherwise you get just so focused. I can imagine.
Yeah, and it's an extreme environment. When you're at the South Pole, it's a beautiful place, and it's an experience that can never be described as well as being there. But when you are there, there's nothing. There's not a tree. There's not a hill. There is nothing.
We walked to all the furthest spots on the base.
Yeah. There's a couple kilometer or a couple mile area you can walk to, around, and that's it. And there's no feature. There's no trees. There's no rocks. There's no wildlife. There's no hills. There's no uneven spots in the snow once you get.
Just.
But I mean, we were only there for like a week, and we went to all these places. And if there's people that winter over, so
people spend 8 months or longer there, and so the health and wellness becomes a really important aspect, and especially in the winter because it's dark for 6 months. It's dark, and you might have 50 to 75 mile an hour winds and minus 100 degree Fahrenheit temperatures, and so outside is not really on the menu.
So inside needs to be a place that you want to be welcoming and friendly and all that sort of stuff.
Yeah, I mean, and I don't know. It kind of surprises me that this is the South Pole of Earth, and they have things like gym equipment and stuff there, or they have a greenhouse there, and that all had to be flown in on a Herc, and it all had to. It's 12 hours on a Herc from Christchurch, which is the nearest place they could have staged,
And then a human put them together down there.
Yeah.
Okay, we are at 3:30. Thank you so much for watching, you guys. Kylie and John, thank you very much for sharing from your expedition down there. I look forward to joining you next year. Thank you very, very much. Where would you recommend, is there a website to see some of the all-sky-cam imagery and the time lapse, all sort of stuff from there? Where can people who are watching who want to see this stuff go?
Yeah, we can link you. So Mark provides real-time data. If you guys ever want to know what the thermospheric winds are doing over Alaska.
Hey, yeah.
Mark has a website that he maintains that with. I can post a link for that. Here at the GI also, a lot of our instruments are co-located with all-sky viewing cameras that Don Hampton at the GI is another gentleman I could speak quite highly about as well. He maintains. So if you want to see what the weather's like where we're doing these instrument data collections.
Or just watch Cool Aurora.
Or just watch Cool Aurora, yeah. We can also provide a link for that as well.
That'd be great. They're beautiful to watch.
Those are also turned into 360 videos.
Yeah, so Jason Arns here at the Geophysical Institute that works for Don Hampton, he has recently created a project to do 4K virtual reality Aurora viewing every night autonomously.
All right, you guys got to go because they're going to find this stuff right here. Best of luck with your rocket mission, and I know that you can sign up for a text alert.
Yep.
I understand from Poker Flat. So visit the Poker Flat Facebook page, and the information is on about that. I'll bring you guys in closer here so you can see you right up close. Thank you for taking a little bit of time to talk with me today. Thanks a lot.
Yeah, no problem.
Thanks.
Thank you.
All right. Bye, everybody. We'll post the video here. Share it with all your friends. Bye.